Hi friends, welcome back to Mule 4 series of learning videos. I am siva.thankamanee, an integration technical architect. So recently I came across some use case which even the experienced members are struggling to find out the concept behind how the data wave is working to achieve that particular transformation. So I thought I can deep dive taking that particular exercise as a use case, and I can come up with a series of exercises, probably 5 or 6 videos from today. So you can expect multiple videos from today onwards. So in this video, we are going to take one complex XML, and the XML as such is easy, but the concept behind will be difficult to understand unless you know thoroughly about how it's happening behind the scene, and then you want to deep dive into deep sea, like 5,000 feet below sea level, and then only you can understand the functionalities and the concepts behind how the data weave is designed to achieve the transformation. Let's get started. So here is a simple XML. The XML as such is simple, but we are going to see how the concepts behind and the motivation behind transforming such XML. So assume that always the external system provided XML might not be in a canonical form, or in the easy way how we expect the resultant data to be. So you can always expect in their native format, which you need to transform always, which you don't have any control over the structure of XML. So such XML is here, and you can see here there are several tree branches where the data is designed into complex structure. For example, the whole employees having under the department, you have multiple departments, and in one department you have department details, and you have employees tag, and under the employees you have employee, which is here. So you have employees, which has one to many from employees to department. The department has one to many relationship between department and employees, and employees have one to many relationship. Employees can have multiple employee. So one employee can have details further field level, which will be in the canonical form. So only employee is at the canonical level, and all the others are having branches. So you can see here the XML structure is like a tree. You have several branches, and it the leaves branches to sub level. So what we are going to do is we are going to make the structure very simple, and then we are only focusing on the data and not at the structure level, so that you can use this data in a whatever destination format that you might require. So this XML can be compared to a different structure. For example, namely for online order, you can have orders. The orders can have different dates, and one particular date can have multiple customers. One customer can have multiple orders. One order can have multiple items. So wherever you get large XML, you kind of have this structure internally buried, and you always need to handle the data in such a way that you take it out and then bring it into canonical form. So the canonical form is not always complex, and it's always deals with one single entity. For example, here canonical form should deal with one employee, or it could be multiple employees, but it should be pertaining to employee and not with the department or not with country, etc. So once you have this canonical form, you can transform into department wise or country wise or alphabetical order of the name. So you can bring it into different format how you need it. So this is the XML that we are going to form a metadata in our Mule 4 flow, and then we are going to transform into the canonical form. Let's get started into the demo. So here I have basically designed a basic framework to reflect whatever input given. So always it's best way to start with reflecting whatever payload is given as a response before you start doing it. So I have done that already, and I've created a basic framework, and I have the transformation which results in payload. And for simplicity, I have given JSON, so that whatever we discuss can be understood easily. So basically we have given XML, which is defined here in the metadata, and I have used this employee. If you see here, this is the employee structure that's taken from the input XML. So you know already that I'm assuming that you already know how to define this metadata based on this XML example. So let's get into the topic straight away. So what we are going to do is first we are going to iterate. So for example, you need to iterate different departments because you have multiple departments. And after that, this is where it's getting complex. So people will be familiar to iterate it using the map with this given array format. But however, when you have array of arrays inside it, I mean, normally the beginners might get uncomfortable and then complex. I'm going to make those beginners or even advanced members feel easy while converting such complex XML. So let's go one by one, and then first what we are going to do is we are going to reflect the same payload structure. So we'll, for example, employees and department. So let's say employees, and employees have multiple departments. So we are going to iterate it. So payload dot employees dot department. So this is what we are going to iterate, and we have already seen in one of my previous data weave tutorial where you need to have this a small asterisk symbol here that serves as a wildcard that retrieves all the sub-elements of the particular tag. So there are several department tags under employees, so we are introducing this asterisk that serves as a wildcard to retrieve all the elements. And then we are going to map, we are going to iterate with an element called department. So I have mentioned it as dip, and then we will say index, and we will introduce curly brace so that the data weave doesn't complain. And here, so we are going to do it meaningfully. So under the department, we should always have department details, but we are not going to worry about it, but we want to iterate the employees next. So this is under which we are going to say employees, where we are going to repeat the element under department. So now you have taken one department. So under the employees, you have taken one department in hand. So that department has multiple employees. That's what we want to iterate internally inside the map. So it's basically array or array contained in the array. So we are going to say dip dot, we are going to say employees, and again we need to place this asterisk because under the department you have multiple employees. So you have to put employees dot multiple employee. So you have to put employees dot choose employee, and which is an array. So we map to the secondary level here, and then which this level is called employee comma position. So now we are going to have a simple employee where we will say name. So we are going to iterate now the name from this secondary level, EMP. So So I forgot the word map, sorry about that. So now if you put employee dot, you will get the employee specific details. That's what we want. So now we are able to get this full name in hand. But at the same time, we want all the other details also. So how do we get that? Now we want a department, because while in the process of converting to canonical form, you need to get all the details available under different branches. You need to bring it under the leaf node so that you are converting it into canonical form. So department name is taken from this upper level. So even though you are in level 2, you will be able to access the parent level here. So department dot department name, and then you want to handle designation. Designation is available at the parent level, you can handle it, and then country the employee belongs to, that is also available at the department level. And now you have basically taken department name, designation, country, employees, and then also you want to take the employee ID. So that we can put it here in the first place. So now that has to be available from employee dot ID. So because it's an attribute and it's not a field, so we are introducing this at symbol. So now we have iterated and then brought it into the meaningful format, but still we have a long way to go. So let's see how this works first. So I'm going to save it. So let me explain it in a simple way. So first we are iterating the parent level, which is department. Let's go back to the XML. So we have employees have 4 departments. So you want to iterate department first. So that's what we have done here. So inside department, you have array of employees under the employees tag. So that you want to iterate because you don't want to miss out the individual employee details. That's what we have done here at the secondary level. But the individual element of the parent level has to be taken from this parent object, which is DEP, which is department. So from that you can take and retrieve the subfields and then you can iterate it. So this is very simple, and let's restart that. It's already restarted. Let's see how this works. So you can see this is what I'm going to explain, which I meant deep dive. Now you see the structure is very complex. Let me copy this and then show you why this is complex to handle. So you have say element here, which is employee, and inside it you have an array, and that array contains a single element, not an array. So that contains a single element. That again contains an array. Again that contains an element, and you have the fields. So this is very complex to retrieve and iterate it to put it into the format that you require. This is what we are going to see how to avoid it, and this is what I meant here, the complex structure. You want to make it simple. How do we do that? It's very simple. So we are going to make some simple changes here. So instead of considering this as a field, and we are going to consider as a bag of elements, which is an array itself, without considering as converting into fields in different with a particular field name. So what we are going to do here is, and we are going to remove this structure. So we are going to remove this branch and then straighten it at the trunk level. So this is what we are going to do, and at this level we are going to introduce open curly bracket, open parenthesis, and we are going to remove this corresponding curly brace, and then we are going to introduce parenthesis. Now the structure is removed, but still the data is maintained. And in the same way, we are going to do it for at the employee level. So what we are going to do is, so we are going to remove this structure, and we are going to remove this employee branch, and we are going to make it as trunk level, and we will introduce this bracket, and we will instead of by removing this, we can put it as parenthesis. So you see this error is removed, and what we are going to do is we are going to save it, and we are going to restart, and then let's see how the structure is modified now. Now you can see here some unnecessary structures are removed. Okay, we will copy this and then we will further explain it, and let's investigate this. So now let me move it to the other view. See, the complexity of the structure has been reduced. See, there is no further level, so it's an array of arrays now. So it's converted into the simple form. It contains 2 arrays. So this complexity is removed, and you only know employees contains an array of arrays. So you all know that array of array can be simply removed, and array of arrays can always be brought into one dimension by using flatten. So that's what we are going to do by flattening this employees array of arrays. So let's go back and let's flatten it. So employees is what we are going to flatten it, and let's remove this, and we will introduce this parenthesis at the master level, and this is what we are going to do, the flatten. Simple. So we made array of arrays into a singular array by using flatten function. So saved it, it's restarted, and let's see how the structure looks like. Now you can see here the structure is further simplified without any complexities. Let me copy this. Let me go back. And now let us remove this one, and let's put it here. Let's move to the other view, and let's paste it. Now I'm moving it to the other view. Now you can see this again, further complicated structures are removed, and it's very simple. Now it's an array of employees. Simple. All employees are removed with the complicated structure. Now it's all brought into canonical form. So now you have a singular group of elements, and you can deal with this in whatever way you want. Now we want to count the number of elements, whether they are intact or not. So let's count how many name is available. So by counting full name, let's see 24 matches, and then let's see whether we got 24 or not. So we need to count, it should be 12. So let's count it properly. So we have only 12. So whether we have 12 or not, we need to count ID. Let's count it. We have 12 matches. So the number of employees have been brought properly, and we got all the necessary details which are at the parent level, which are department name, designation, and country here. So now we can iterate it simply and then bring it into different format. That's what we are going to do now. So you can either go for a completely different transformation, that if you want to change the name. I mean, just for making your understanding very clear, I'm going to make some transformation here. And here you can use this iteration by using map. If you want, if you want only the required structure in the canonical form, the transformation is already completed. Now I'm doing one level to say how you can make use of this array using the same data weave instead of going for another one completely different data weave. So see, since this itself is an array, you can use a map of employee and position, and you can say I mean, just I'm changing the ID, I mean, like field name. so that you understand better, because this is considered to be a new array which serves as an input, which you can use it. So for example, employee dot, you can use this ID here. And full name, and you can use employee dot name. Let's see how this is turning into. Let's save this. It's restarted. Now you can see here the data is transformed into the different field name. Let's understand this better. So what are we doing here? So we are considering the whole transformation as an array. That is the reason why we flattened. And you can iterate it by using another name, and you can bring it into whichever format you want. This is very helpful in case the incoming XML is complex and you want to convert it into canonical form, and then you want to bring it into some other format. Why adding more transformation logic here makes sense? Let me give you. So what we are going to do is map. We are going to give order by $.id. So we are going to bring this map here. So this is helpful if you want to make some processing by ordering it out and then bring it into a different perspective. Let's save this. And then let's see if this is getting ordered or not. Now you see here it's ordered by 11, 12, 22, etc. So this is one of the advantages on how you can handle the previous set, or you can leave it and then bring some other transformation based on your convenience. So this is also not taking much time, and because this is only taking 15 milliseconds, and this is not bringing any performance degradation. So that's it in this video, friends, and I brought this concept only to make you understand the intricacies of how the data weave works, or how the data weave is intended and designed, so that you leverage the complete power of data weave, so that you can minimize the transformation logic. You can make it simple, or sometimes instead of making 2 or 3 complex transformation, you can bring it into very comprehensive under one data weave. So hope you felt it useful and liked it, and if so, please hit thumbs up button and subscribe my videos. Soon I will come up with more interesting and useful topics. Thanks for watching my video. Bye.